Okay, this is lesson 22. We're going to talk about absolute value functions and reciprocal functions. Okay, so the first one is f of x equals the absolute value of x minus 2. If you just had f of x equals the absolute value of x, that means no matter what x is, y is going to be positive. We know that. It also means that, like if x is 6 or negative 6, the answer is still going to be a positive 6. So it looks like a V. You know, where, like if this point is 3, 3, and then the reflective point is negative 3, 3, like that. This means that the graph has shifted. It's shifted according to the y-axis down 2. That's what that means. So if we were going to graph that, we would just go down 2 from where this original function, this one isn't shifted at all. This is called your parent function. So this one just shifts down 2. Now we can double check ourselves in case you're wondering if it's right or not. So you can just say, well, when x is 0, it's going to be negative 2, right? When x is 1, it's going to be negative 1. And when x is negative 1, it's going to be negative 1. When x is 2, it's going to be 0. And when x is negative 2, it's going to be 0. So you can see it is taking on the same shape as this one, just shifted down 2. This point is 0, negative 2. Okay? Okay, so what do you want to do about this graph right here? Well, this is a reciprocal of, it's the reciprocal of, I'm going to call it f of x, because that's called g of x, of this function right here. So the easiest way to do a reciprocal graph, because you're not using calculators for this, is you're going to graph this one first, and then I'll show you how to do the reciprocal. Okay? So this one is similar to the one before. It's shifted down 3, but this negative 5 inside the absolute value means it's shifted along the x-axis as well. So not only did this original point here go down 3, but with x minus 5, it's going to go to the right 5. I know that sounds backwards to you because it's minus 5, but that's the way it works. So we're going to go over 5 and down 3. Okay. So when x is 0, I'm going to get a 2. Now that's 5 away from where this one is. So when x is 10, I should also get a 2, and I do. So what I want to know is where it's going to cross the x-axis there. So how can I get a 3 out of this? Well, if this is a 2, then this becomes 3 and it'll be 0. So when x is 2, it crosses, and that means since this is a symmetrical function, that means it should be 1, 2, 3 right there, so 8. That makes sense. 1, 2, 3 right there. Okay? So this one's going to look like this. And you should really label all these points, but this point right here in particular is 5, negative 3. Now, that's what we're going to start with. Now we need to graph the reciprocal of that. So what we want to do is we want to get this graph, and then we want to draw asymptotes wherever this graph is equal to 0. So you draw asymptotes like that. You notice I'm using another color. I suggest you do that. Then what you're going to do is you're going to pick a point to the right of the last far right asymptote and plug it in and see what you get. So this point right here was an 8. So this is 9. So if I put 9 right here, I'm going to get 4 minus 3. I'm going to get a 1. So I get 1 over 1, which is 1. So at 9, it's up above the x-axis. Okay? It's up above the x-axis. If it's up above the x-axis at 9, it's going to be up above the x-axis at all of these. But it's going to look like this. It's going to hug these asymptotes. Now, it should reflect on the far other side here. So I'm going to put in like a 0. If I put in a 0, I get, that's a 2. That means that's 5, so that's 2. You get 1/2. So at 0, you get 1/2, which makes sense. It should be coming down because we know at 1 it's going to be the same as at 9 because they're symmetrical. So those are going to look like that. Now we need to know what's going on here. So when this is a 5, I get negative 1/3. Okay, if x is 5, I get negative 1/3. Because I did have negative 3 when it was this one here. Okay, so negative 1/3. That's way up here. When it's a 3, I'm going to have a 2 minus 3. That's negative 1. I'll have a negative 1. So when it's 3, I'm going to have a negative 1. That's because this is going to look like this. It's not going to cross the x-axis. It's going to look like this. So these little parts here are hugging the asymptotes. And the way I got that again was, first I graphed the original function before it became a reciprocal, which is what that is. Then I found where it crossed the x-axis and made asymptotes. Then I checked a point to see if I was above or below it by just plugging it in. And I knew it had to look like this. It should reflect over here. I plugged a point in the middle of this, figure out if it's above or below, which it should be below, and then I know it's going to do this. Okay, now let's look at this one. It says graph the following set on the real number line. Okay, so there's two ways to look at these, okay? We're going to first look at algebraically. And I'm not sure, if you've been taught both ways, but I'm going to teach you both ways now. So algebraically, when I have something like the absolute value of x minus 1 less than or equal to 4, the way you solve that is you think first, what if this quantity inside here, the whole thing x minus 1 was positive? Well, then it's just going to be a positive, isn't it? It's going to be positive anyway, not because of the absolute value, but because I just said it was positive. So if it's positive, I don't really need my absolute value. But if this whole thing ends up as a negative, depending on what x is, then I do need my absolute value because it changes the sign to a positive. So if x minus 1 ends up being a negative number, my absolute value, in effect, changes the sign of it. So algebraically, I can solve both of those. And let's do that. This is negative x plus 1 less than or equal to 4. This is negative x. Subtract 1 from both sides. Now remember, when you multiply or divide by a negative with an inequality, you have to change the direction of the inequality sign. So it's going to look like this. So what does that look like on a number line? That means I've got negative 3 and I've got 5. X has to be greater than or equal to negative 3. Right, going this way. X has to be less than or equal to 5 going this way. Now, you can check yourself, see if that makes sense. A 0 is in between there. If I put a 0 in here, I get a 1, and 1 is less than or equal to 4. Okay, so the answer here is that x is less than. Well, no, it said to graph it, so the graph is the answer. Okay, so graphically, what do you do? Well, graphically, you try to understand what this is talking about. And what this means is that x is less than or equal to, is less than or equal to 4 from, and then you're going to use the opposite sign here, from 1. So x is less than or equal to 4 from 1. 4 from 1. Wait a minute. Okay, let's just get 1. Okay, here's 1. What's 4 from 1? 4 away from 1. Well, 4 away from 1 this way, go 4 this way, and you end up at 5. Go 4 this way, and you end up at negative 3. And it's saying it's less than or it's equal to 4 from 1. So it could be 3 from 1. It could be 2 from 1. It could be 1 from 1, that kind of thing. So that means, of course, it's or equal to, then you get the same graph. You need to think about this right here. This is really important later when we talk about absolute value functions, especially in calculus, to have that understanding. Okay, let's move on to page 2. In page 2, the first thing it asks you to do is to graph the following set on a number line. So this is multiple choice. So let's think of this the way I just said it. Let's do x is less than 4 from negative 2. that means like 4 spaces, okay? Okay, so negative 2. So if you had a negative 2, it says less than 4. So if you go 4 this way, you end up at 2. If you go 4 this way, you end up at negative 6. When it says less than 4, that means it can't be exactly 4. So it should look like this. So which one looks like that? It'd be this one, right? Give y'all a chance to look at it. So it's A. Okay. Let's look at this next one. It says to sketch the graph of 2 over x plus 2. I'll tell you, let's skip that one for right now, because that one's going to bring up something out of order of what I wanted to teach you. Okay, sorry. But let's go on to this one, because this one will be a better number 2 on reciprocal functions than the other one. We'll go back to it. Okay, so first we're going to sketch this one. Okay, now we know that y equals x squared. We know what that looks like. It looks like a parabola like that. So if y equals the opposite of x squared, that means that whatever your x's are, whatever you get for x squared, then you got to change the sign. So for A, that should be intuitive, that instead of looking like the parabola like this, that it's going to look like a parabola like this. Now you're going to do these graphs on graph paper, and you're going to be real exact with it and all that kind of good stuff. But it gives you, it's good to have a good idea of what you're doing. So let's just check it. Obviously, when x is 0, it's 0. When x is 1, it's going to be negative 1. Okay, so if it's 1, we'll call that negative 1. Okay. When x is 2, you get negative 4. So at 2, let's up down here somewhere, 2, 3, 4, right? You get negative 4. So that's making sense. And then obviously, if you're squaring the same things, you're going to get the same things on the other side. Okay? Alrighty. So B now says graph the reciprocal of that. So the easiest way to do that is on the same graph. So the asymptote is the first thing. We look for where it goes through the x-axis, which is right here. So this becomes an asymptote. That means it's not going to touch it, not going to cross it. Okay? Then what you want to do is you want to check a point on each side. So if I put a 1 over here, I get negative 1 on the bottom. That's a negative 1. So if I put a 1, I get a negative 1. If I put a 2 here, I get a negative 1/4. So at 1, I had a negative 1. At 2, I had a negative 1/4. That's way up here. Okay? At 3, I'm going to have a negative 1/9. So it's coming up. But it doesn't matter what I put in this x. I can never make that bottom a 0, can I? And it will always be negative because of this right here. In fact, if I put like a little fraction like 1/4 in here, which gives me 1/16, I get negative 1/16 in the bottom, but then that has to flip. So then I get like a negative 16. So what that means is this one's going to go straight down like that. And it's going to mimic the same thing on this side. And you can plug some points in and check it if you're not sure. So I wanted to do an easier one before we flip over on the other one. Okay, so let's go back to that one. Okay, now that one's got a little bit extra stuff because it's got a 2 in the top. So what I want you to do, though, is I want you to look at it and think the most basic one that this looks like of all the parent functions is 1 over x. Okay, now you should know what 1 over x looks like, or you should be able to quickly graph it. So when x is 1, y is 1. When x is 2, y is a half. And it's going to keep going, as x gets bigger, this number gets smaller. If you put a half here on the bottom, it flips up, becomes a 2. So this one looks like this. It's going to look the same way when x is negative, except it's going to be a negative answer. So if you have negative x's, it gives you negative answers. So it's going to be over here like this. Again, you're going to do it on graph paper and get some actual points, and all that's good. Okay. Now, that's what 1 over x looks like. Okay, so y equals 1 over x looks like this. So then you say to yourself, well, if it's x plus 2, what does it look like? Well, if you add 2 to the x, you take the same graph, but you move it to the left 2. So like this point right here, well, let me just do it this way. You notice how the y-axis is acting like an asymptote, right? So let's move that asymptote over 2. Okay, so we're going to move it over 2 right here, and we're going to draw here. Then we're going to move this point over 2. So it was right here. So 1, 2 goes here. Let me see, at -1 here, this was -1. Okay? -1 there. So this point right here, we're going to move over 2. So at -1, we're going to move it over 2. We're going to move it over 2. So at -1, we're going to move it over 2. So get it right here. I didn't do that in red, sorry. Okay, so that means this graph, now let's just do it like this, is looking like this. And this one is y equals 1 over x plus 2. Now, we didn't compensate for the 2 in the top yet. We're just taking it little by little, okay? Now, if I wanted to graph this, but then compensate for the 2, then what I want to do is I want to think of this, okay, as y equals 2 times 1 over x plus 2. Because all that tells me is, once I get this graph, whatever I had for my y, I'm just going to multiply it by 2. So what does that mean? Well, I already have an asymptote over here at -2. So over here at -2 is my asymptote. This point right here is -1, 1. Right? So the y part is 1. Multiply it by 2. So at -1, it's going to be at 2. Okay? This point right here is what? -3, -1. So -1 is the y. Multiply that y by 2. So if you had -1, you multiply by 2, you get -2. So we're going to be down here at 2. And all that has happened here is this whole thing is just going to look the same, but it's just going to shift. With a multiplier of 2, it makes that one go up, makes this one come down. So we had one more step in here. That's why I didn't want to do it as the second example. And I hope that helps.